Okay, second assessment over a couple of shorter standards. This front back is one standard, it's completing the square. And then you got your complex numbers. By the way, complex number is an I. Okay, that's what a complex number is. Okay, find the value of C that creates a perfect square trinomial, then we're going to factor the trinomial. Okay, so C is equal to B divided by 2 to the second power. So this is my B term, okay? By the way, A is an implied 1, okay? We just got to find C. So B is negative 14. You can just put 14. Negative 14 divided by 2 is negative 7. And then we take negative 7 to the second power. That's not negative 49. Anything to the second power is positive. Anything times itself is positive, okay? I don't care if your calculator says negative 49. That's because you're not punching it in right. Okay, so C is 49. And then we got to go factor it. So the GCF's 1. We just go make our table. 1 times 49 is 49, positive. And a cool thing that happens when you do B over 2 to the second is this is a perfect square, 7, 7, because we see we're trying to add to the B term negative 14, and it does it every time, okay? Okay, so with A as a 1, we don't need the 1 anymore, okay? We just write x minus 7, x minus 7. You will be docked a point if you don't write that as x minus 7 quantity squared, okay? There's no balance to this. It's not an equation. It's just an expression that you need to rewrite, okay? When you're rewriting equations, you have to think of balancing, but just a simple expression without an equation, no. Okay, number 2, rewrite the following quadratic equation in vertex form. So that's standard form. We have to rewrite that in vertex form. Remember, a quadratic equation is one where the variable's highest power is a 2. Okay, so you're going to make a print. You put a 1 there. Kick out minus 20. Now, if that's a 1, that's good. You don't have to divide. Okay, do not divide. Because that's A, that's B, and we have to find C. Okay, so first, C equals B divided by 2 to the second. B is 6. 6 divided by 2 is 3 to the second, and that equals 9. Okay, so my C value is a 9. But now I have to balance because we had an equals, okay? So if I brought a new number into one side of the equals, I have to bring it to the other side. So what am I balancing? Well, we're balancing 9 and then check in front. There's no multiplier, nothing I divided by and pulled out here. So I just balance 9. So if I added a 9 here, I have to add it over here, but I really don't want to have y plus 9. So then I quickly subtract 9. And then from negative 20. Now I rewrite this expression in factored form. Okay, so 9, A times C is 9, positive. You're adding to get positive 6. You can put 2 negatives to begin with. You'll switch them both to positive because 3 and 3 adds up to negative 6. So right there. Okay, so A is a 1, so you can just rewrite that as x plus 3 times x plus 3, and then you're going to have minus 29. Now rewrite that as a quantity squared, so it's x plus 3 quantity squared minus 29. Now the way to check at the end if you did this right, okay, is to make a coordinate, okay, just pick 1, 2, something, plug it in here. So if I plug 1 in, okay, I got negative 13. Now I need to plug 1 in here. And I hope that's negative 13. It is. So these are equivalent equations. They're just different formations. Okay, number 3. Rewrite the following quadratic equation in vertex form. Okay, so first we make a parentheses, kick out the plus 9, ABC, but my A has to be a 1. The only way that happens is if you divide by 2, but you have to divide both of these by 2, not leave the 1 at this a 2 and leave that as a 12, okay? So you kick 2 out, and it keeps coming down, and then I get 1x to the second plus 6x. I can't repeat that enough, okay? You're dividing that by 2, but you also got to divide that by 2 as well. Not the 9 because I kicked him out, but just these first two. Don't just leave that, make that a 1 and leave that at 12. That isn't going to fly. Okay, now to find the c, when I'm completing the square, c equals b divided by 2 to the second. So b is 6. See, if I put 12 there, it's going to be wrong. Okay, 6 divided by 2 is 3 to the second, and that's 9. Okay, so I'm going to bring in 9. Now I have to balance the equation. Okay, so I brought in 9, but I didn't just bring in 9. 9 is multiplied by 2 this time. So I'm balancing the product of 9 and 2, which is 18. So I add 18 to y, but then I quickly then go subtract 18, and then subtract it from 9. Okay, now it's time to factor. Okay, so 1 times 9 is 9, positive. Okay, so negative times negative, and we're adding to try to get positive 6. Now 3 and 3 makes 6, but that makes negative 6 the way we have it, so we make them both positives. Okay, so it'd be x plus 3, x plus 3, and then 9 minus 18 is negative 9. The heavy lifting's done at that point. So 2x plus 3 quantity squared minus 9. Again, for those wishing to check their answer for accuracy, pick a number. We'll put 2 into the original, into the standard form quadratic equation. And I got 41. Now I put 2 in here. 41. Okay. You don't have to do that. It's just me checking for accuracy. So again, compare number 2 and number 3. You kick the constant out, you're going to get a new constant. That's c's constant. If it's a 1 already, you don't have to divide. Okay, b over 2 squared, then you balance in 9. If it is not a 1, okay, you need to get it so it's a 1 by dividing, but then you got to divide the x. That comes as a match set. You can't divide one without the other. So it's 6 is my b divided by 2 second, not 12. Okay, and this one's pretty easy. Find the value for k that creates a perfect square trinomial. We don't have to factor it, okay? So here's what you do. You find the number times itself, that's 81. That's 9, but then you have to take 9 times 2, because if I make a t-chart, 9's on there twice, so 9 times 2 is 18, so k is 18. Because if you took 81 to a t-chart, it would be 9, 9, and that adds up to 18, okay? Okay, that's one standard. That'll be the second time on tomorrow. Now you got to review complex numbers. Complex numbers is all about i's. Complex roots, complex numbers, whatever you want to call them. They're I. Evaluate I to the 8th. So break that down into I to the second, a group of, and all those I to 2, 4, 6, 8, and all those become negative 1s. Okay, find that product, it's positive 1. There's an even amount. Sometimes there's an odd amount. You just break it down, you can't go wrong. Okay, what do we have in the middle? We have an addition sign, so I don't need to do any multiplying. Blank plus blank I. So 3 and 8 make 11, and then 2 and negative 6 add up to negative 4. Bam. Blank plus blank I. Now you got subtraction. Now you're going to do it the same way, but you got to make that a positive, and every number in the second one goes opposite. So that 2 is positive, not anymore. Now it's a negative. That 9 that's positive, not anymore. Now that's a negative. If something would have been negative, I would have made it positive. So 5 and negative 2 add to 3, and then negative 7, negative 9 add to negative 16. Bingo. Okay, now you look here and there's no sign. That's multiplication. You have to employ the distributive property, the FOIL method, whatever you would prefer to call it. So I take 5 times 8, and I'll write FOIL here so you know what I'm talking about. 5 times negative 5i, 2i times 8, 2i times negative 5i. Okay, so that's 40. This is negative 25 with I. This is 16 with I. And this is negative 10 with I to the second. But since I to the second is equivalent to the value negative 1, negative 10 times negative 1 is a 10 constant. So these two are now matching terms because they're constant. Okay, so combine those, that's 50. Combine these, you get negative 9. Boom. Notice all the answers kind of look similar. You just go to different means to get them. All right, now you got some fractions, complex fractions. Not really called complex fractions, but fractions where you have to get the I out of the denominator. Okay, so this is top, this is bottom. Now look on the bottom. You don't have a plus, you don't have a minus, that's why there's no parentheses. Then you can just multiply by I, not 3i, just I. Okay, and on top we distribute our I. Okay, we're going to be taking I multiplied by 8 and I multiplied by 6i. So that's just 8 with I here. And this is going to be 6 with I to the second, but then that turns into a constant because negative 1. 6 times negative 1 is negative 6. So it'd be negative 6 plus 8i. Now the bottom is where I need to get rid of the I, which I will because I'm going to take 3i times I, and that's 3i to the second. But that then becomes a constant. 3 times negative 1 is negative 3. Mission accomplished. I is no longer in the denominator. Okay, number 6. Now, this time you have a parentheses on bottom, so you need to make a parentheses. You can't just do I. You're going to write 8, you're going to write 5i, but you need to switch the minus to a plus. And likewise up here, okay? Okay, so the top and the bottom. So the top is, both of them are FOIL. Okay, 4 times 8. 4 times 5i, 7i times 8, 7i times 5i. So that's 32, 20i, 56i, 35i to the second. But that becomes a constant because it's times by negative 1, and now it's just plain old negative 35. So I combine those. That would 32 plus negative 35 is negative 3. Add those. That's going to be plus 76i. Okay, now in the denominator, we have 8 times 8. 8 times 5i. Negative 5i times 8. And then negative 5i times 5i. I know this problem is not a lot of fun, but we're going to grind through it. So 64. 8 times 5 is 40 with I. Negative 5 times 8 is negative 40 with I. And what do you know? They're going to cancel. And that's negative 25 I to the second. But again, I to the second is actually negative 1. So multiply, you get 25. So 64 plus 25 is going to be 89. Bingo. Now I have just a constant in the denominator. Okay, factor the expression. If you find the two answers for x, I'm going to dock you points. Okay, it's not an equation. You're not finding the roots. You're not finding the solutions. Factoring. It's two terms. The parentheses are your answer. So GCF. and then dots. GCF's 1, don't need it. Dots. Well, yeah, 4 that's 2x times 2x, and then 9's 3 times 3. But the whole point of this is if you don't have the minus, because D stands for difference. If the difference is not there, we compensate for that by putting an I behind the constants, okay? So that's the answer. 2x plus 3i times 2x minus 3i. So I'm not finding the answers, okay? Now the next one, solve the equation. Now I'm finding the answers. Okay, you got x second. Do you have x to the first? You don't, so don't factor it. Just get that, make a wall here, get x squared by itself. Minus 4, that's 54. Divide by negative 3, that's negative 18. Find the square root of negative 18. Okay, we got a negative square root. You got to have the I, and then look up on the board, and you will find that 18 is divisible by 9. So 9 goes in the first square root, and then 18 divided by 9 is 2. Okay, so this becomes 3. Don't leave it 9. It becomes 3. So 3 square root of 2, negative 3 square root of 2, and we just place the I in those, okay? Okay, 2 answers. Those are complex roots, meaning I is a solution. Okay, 2 answers, but you have x to the first. Okay, your zero's there, and you got 3 terms. So GCF and table. GCF's 1, no need, wouldn't do an x, wouldn't do a negative. Okay, 1 times 12 is 12, so positive 12, negative, negative, okay? Add to try to get to negative 5. This is impossible, okay, because that's negative 13. Divide by 2, you get 6, that's negative 8. Divide by 3, you get 4, that's negative 7. This ain't going to work, okay, so it's prime. Okay, so quadratic formula time. Okay, you can do it in there, or you can do it here. Opposite of b plus or minus the square root b squared minus 4ac, b squared minus 4ac over 2a over 2a. So opposite of b is 5. b to the second is negative 5. For a is 1, c is 12. And then a on the bottom is 1. Okay. Okay, so we got 5, 2 times 1 is 2. Now let's evaluate the discriminant. Negative 5 to the second, that's negative 5 times itself, that's 25. It's never negative. 4 times 1 times 12 is 48. That's negative 23, okay? With the negative square root, we extract I, and we just put I up here with the square root of 23. Okay. Now that accounts for 2 solutions. We can just circle it. We can't simplify it with the I. Okay. You don't keep adding, subtracting any of that. Okay. Those are called complex roots when you get I. Okay. Work on the other one as practice and then assessment tomorrow.